Hi students, let's continue our lesson on relative velocity. So last time we saw various examples, we analyzed various cases when we were dealing with polar vectors, relative velocity of polar vectors. Now let's look at these questions. Question 1. Two cars A and B move with velocities 25 kilometers per hour north. The direction has been specified. North and 75 kilometers north respectively. Find the velocity of A with respect to find the velocity of B with respect to A, and we are asked to interpret our results. How do we solve this question? The second question is also there. We are going to solve them, all of them. So take your time, write the question, digest it as I solve. Pause the video, write the question, and follow the solution I'm doing. So let me create my board. Solution. When we check the question carefully, we are given two velocities. The directions have been given. A is moving north, B is moving north. The units are the same, all right? So I can draw it this way, like anyhow you want to use it, something like this. So A is moving with 7, is it 25 or 75? 25 and B is 75, okay? So 25 kilometers per hour, and B is also north and it's 75. Right, and we are asked to find the velocity of B with respect to A. How do we write it? We want the velocity of B with respect to A. This is how we write it. And according to the formula, it is given by VB plus minus VA. All right. And you could see these are parallel vectors. They are moving northward. So we assign positive to it. So this becomes VB minus VA. All right. The negative is already in the formula. And because both of them are moving due north, we are not going to negate any of them. So it's going to be 75 minus 25. And what do we get? 50 kilometers per hour. So that is velocity of B relative to A is 50 kilometers per hour. And we are asked to interpret our results. What do we mean by interpreting our results? You need to first understand the meaning of velocity of B with respect to A. It means that they are cars. Let's check the question. They are cars, right? So it means that this VBA means velocity of B with respect or relative to A. So what it means is that how an observer in car A will see car B moving. How does the meaning? Velocity of B with respect to A means that if an observer is in car A, how is he going to see car B moving? That is the meaning of velocity of B with respect or relative to A. Relative to A means how the A will see car B moving. So how do we interpret this? Let's check the original values. You could see that how is what I'm saying is that how the meaning is how is an observer in car A see car B moving. That is the meaning of velocity of B relative to A. If we find let me talk a bit. If we find VAB, this means that this one means that how an observer in car B sees car A moving. Sorry for the interruption. Do you get it now? Yes. So you need to first understand the meaning of these letters before you can interpret it. If you don't understand the meaning, you can't interpret it. So if you have VBA, this is the meaning. If you have VAB, this is the meaning. So the question asked us to, we were asked to calculate VBA. So you use the values to now draw your conclusion. At first, so it means that for this question, this is what they want us to find. So you can go back, pause it, and write these ones somewhere. So here, this is what they want us to find. How is an observer in car A, C, car B moving? That is the B meaning. Originally, what was B moving? B was moving with 75 kilometers per hour, right? According to the question. But when we found VBA, what did we get? We have gotten 50 kilometers per hour. So what has happened to the speed? You see, it was moving with 75. Originally, that is what it was moving with. But relative to A is seeing that B is moving with this velocity. Do you know why A is seeing B to be moving with this reduced velocity? Already, this velocity was small already. So that is the meaning. So you could see that to an observer in car A, he will see car to an observer in car A, car B will appear to be moving slower than it is in reality. In reality, it was moving with 75. But when we found VBA, we are getting 50. So an observer in A will see B moving slower than it is in reality. So this is what I'll write. Interpretation. The result means to an observer, okay, to an observer in what? In car what? VB, we found VB. To an observer in car A, car B appears to be moving slower than it is in reality. That is the meaning. That's all. Great. In reality, car B was moving with 75 kilometers per hour. But when you find the velocity of B relative to A, we are getting 50. So in reality, so you could see that to car A, B will appear to be moving slower. But it is not this 50 that it is moving in reality. It is moving with 75. That is the meaning of what we have done here. I hope you are following. Good. Now let us look at question 2. A cyclist moves 6 meters per second opposite to an observer also moving 3 meters per second. So I mean the cyclist and the observer are moving opposite, right? Calculate the relative velocity of the cyclist. Calculate the relative velocity of the cyclist. How do you know this? So you see here, they didn't say this with respect to this. When you go back to the definition, we said it there. If you remember, mathematical definition, go back to this. So if you have velocity of y relative to x, it's the same as relative velocity of y. Okay? So if you come to this question, if they are asking us to find the relative velocity of the cyclist, it's just like this. Relative velocity of y. So we are finding relative velocity of the cyclist with respect to the observer. Do you get it? Oh, sorry, I've changed it. No. So we are, in other words, we are finding the velocity of the cyclist relative to the observer, because he's talking about two things here: cyclists and an observer. But he says they are moving in opposite direction. He didn't specify which one was moving towards the this and which one was moving towards whatever. So somebody can choose to use the north, south, or east and west. Whatever you want to use, you arrive at the same answer. So solution 2. So let me use the east and the west. So let's see, let VC be the velocity of the cyclist. VO be the velocity of the observer. And according to the question, it says that the cyclist and the observer are moving in opposite direction. Okay, so this is VC, and let me say this is VO. Here the direction wasn't specified, so you can choose whichever. So he says the cyclist is moving. What is the value? The cyclist is 6 meters per second and the observer is 3 meters per second. meters. And the question is asking us to find, we want the relative velocity of the cyclist. Go to the question. We want the relative velocity of the cyclist. In other words, in other words, we are looking for relative velocity of the cyclist. It's written as velocity of the cyclist relative to the observer. That is how you write it. So how do you find VCO? It's VC plus the minus of what? VO. And this is what? VC minus VO. Are you following? But check the diagram we have done. They are moving in opposite direction. So because they are moving in opposite direction, conventionally we have to negate this. Alright? If I had made the C towards the west, I would have negated it. So I'll make this negative 3 because it's moving towards the west. Because of the direction we assigned. Are you following? So this becomes what? 6 minus. The minus is already in the formula. Minus 3. And what do we get? We are going to get V CO 6 plus 3. Okay, check it. Okay, and this gives you 9 meters per second. And how do we interpret this? How do you interpret this? Go to the diagram. How this VCO, what does the VCO mean? VCO means that how an observer will see the cyclist moving. That is the meaning of VCO. That is the meaning of VCO. Originally, what was the cyclist moving? Originally, the cyclist was moving with 6 meters per second. Right? It was moving with 6 meters per second. Right. But how is the observer going to see it? That is the meaning of the VCO. The velocity of the cyclist. The relative velocity of the cyclist means VCO. It is the same as is the same as saying the velocity of the cyclist relative to the observer. Okay? But you see that the 6 has now, the relative velocity of the cyclist has now become 9. At first, the original velocity of the cyclist was 6, but to the observer, it is 9. So how do you interpret this? Interpretation. So we say that the result means that to the observer, okay, or to the observer, the cyclist will appear to be moving. Will it be slower or faster? The original is 6, but to the observer you are getting 9, so it's going to be faster. Moving faster than it is in reality. That is why sometimes when you are in a vehicle and another car bypasses you, it's like the car is moving with a very high velocity. It bypasses you with that sound. Shum. I don't know if you have observed it before. It happens a lot of time. It is because of this thing we are doing here. That sound you heard in your ears is not the original velocity of the car. It is because of this thing happening. Because both of you are bypassing each other, your velocity and the velocity of the other car, the velocity of the car you are sitting in and that of the car which is coming to bypass you will add up. The two will add up, and that is what you will hear in your ear. That is what you are going to hear in your ears. So you think that it is moving, it will appear to be moving faster to you. In reality, the cyclist was moving with 9. But you see, because the observer and the cyclist were moving opposite, right? See what the observer is seeing. The observer is seeing that the cyclist is moving 9. But it's not moving 9. Actually, it was moving 6. That is the meaning of relative velocity of the cyclist. So this is what we can write over here. Good. I think on this note, we have done enough on parallel vectors. If you have any question, don't forget to send your question